In this episode, we are focusing on a topic that sounds formal but affects almost every experience people have with technology, whether they notice it or not. Quality assurance, QA, and quality management, QM, in information technology, IT, are about making sure systems, services, projects, and support activities consistently meet real needs instead of merely existing on paper or technically functioning most of the time. For a beginner, the simplest way to understand this is to think about the difference between a system that works once during a demonstration and a system that works reliably for real users under real conditions, day after day, without creating confusion, delay, or unnecessary risk. That difference is where QA and QM live. They help organizations move beyond hoping that technology will be good enough and toward building a repeatable way to define quality, check quality, improve quality, and hold people accountable for maintaining it. Without that discipline, even smart teams can produce unstable systems, inconsistent support, weak documentation, and avoidable failures that slowly damage trust. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful starting point is to understand what quality actually means in an IT setting, because beginners often assume it means perfection or expensive polish. In practice, quality usually means that a service or system is fit for its intended purpose, performs consistently, meets requirements, supports the business process it was built to support, and does not create unacceptable levels of error, delay, or risk. A payroll system can have a clean screen and still be poor in quality if it calculates incorrectly, runs late, or breaks every month during a heavy processing cycle. A help desk can answer calls quickly and still provide low-quality service if issues are closed without really being fixed. Quality therefore combines reliability, accuracy, timeliness, usability, maintainability, and control. It is also strongly connected to user expectations, because a technically working service may still be low in quality if it repeatedly frustrates the people who depend on it. That is why quality is best understood as dependable value rather than technical appearance alone. It also helps to distinguish QA from QM, because the two are related but not identical. QA is usually the preventive side of the effort, meaning it focuses on designing processes and checks that reduce the chance of defects, mistakes, and weak outcomes before they spread. QM is broader and includes the policies, objectives, responsibilities, oversight, measurement, and improvement practices that guide how the organization thinks about quality across IT as a whole. Another related idea is quality control, which is the activity of checking completed work or delivered service to confirm that it meets expectations. A beginner can think of QM as the overall system of management, QA as the preventive discipline inside that system, and quality control as the confirming activity that tests whether the results are acceptable. When organizations confuse these ideas, they often inspect problems after they happen, but never improve the way work is planned or governed. Strong organizations do not depend on catching bad outcomes at the last second. They design their processes so that good outcomes are more likely from the beginning. This topic matters because low quality in IT does not stay inside the IT department for very long. It shows up in missed transactions, slow response times, incomplete reports, failed implementations, repeated incidents, user frustration, and rising operational costs. A weakly managed application update can interrupt sales, a poorly documented process can cause delays during an audit, and inaccurate data can damage decisions made by leadership who assume the information is trustworthy. In many organizations, technology is tightly woven into finance, operations, customer service, healthcare, education, logistics, and communication, so poor quality becomes a business issue very quickly. High-quality work, on the other hand, creates stability that people often take for granted because things simply function as expected. That stability supports trust, which is one of the most valuable outcomes of good QA and QM. When users trust the systems, teams trust the process, and leadership trusts the reporting, the organization can operate with less friction and fewer surprises. Leadership and governance play a major role here because quality does not appear automatically from the hard work of technical staff alone. Someone has to define expectations, assign responsibilities, approve standards, fund improvement efforts, and make it clear that rushing unstable work into production is not a sign of success. When leaders only reward speed, low cost, or visible output, teams may quietly sacrifice documentation, testing, review, and consistency in order to look productive. Over time, that creates a fragile environment where defects increase and rework becomes normal. Good governance gives quality a formal place in decision-making by defining who owns quality objectives, how performance is reviewed, how exceptions are handled, and when unacceptable risk should stop a release or delay an implementation. This matters for beginners because it shows that quality is not only a technical practice, but also a management choice. An organization gets the quality culture it tolerates, and if leadership treats quality as optional, the rest of the environment usually follows that signal. Clear requirements are one of the foundations of quality because teams cannot consistently deliver what has never been defined in a meaningful way. A common source of poor quality is not laziness or incompetence, but confusion about what success is supposed to look like. If users, project leaders, developers, support teams, and management all have different ideas about what a system should do, the final result may satisfy none of them even if a great deal of effort went into it. Good QA begins early by making sure needs are understood, documented, reviewed, and translated into expectations that can actually be evaluated later. These expectations may involve functionality, security, performance, availability, data handling, usability, support, or compliance obligations, depending on the service. When requirements are vague, teams tend to rely on assumptions, and assumptions create inconsistencies that are hard to fix late in the process. Quality management, therefore, depends heavily on disciplined communication, because clarity at the beginning often prevents costly confusion later. Quality also has to be built into the full life of an IT service or system rather than attached near the end as a final check. During planning, quality involves choosing realistic goals, responsibilities, timelines, and control points. During design, it involves thinking carefully about how users will interact with the service, what dependencies exist, what failures are possible, and how the solution will be supported once it is live. During development or configuration work, it includes following defined methods, documenting decisions, reviewing changes, and keeping environments organized so people are not working in chaos. During implementation, it involves readiness checks, validation, communication, and contingency planning in case rollout does not go as expected. After go-live, quality continues through monitoring, support, problem management, maintenance, and continual improvement. This lifecycle view matters because many organizations make the mistake of treating quality as a gate at the finish line when it should really be part of how the entire journey is managed. Review and testing activities are important because they provide evidence that work meets expectations before problems reach users or critical operations. Reviews may include peer examination of designs, walkthroughs of requirements, inspection of documentation, validation of configurations, or comparison of outcomes against expected results. Testing can occur at several levels, such as checking whether a specific function works correctly, whether connected components work together, or whether the overall service behaves properly under realistic conditions. The beginner lesson is not to memorize technical testing categories, but to understand the purpose behind them, which is reducing uncertainty before release and increasing confidence that the solution is ready. Testing is most effective when it is tied to clear requirements and realistic scenarios rather than being rushed through as a symbolic step. It is also important that defects are tracked, analyzed, and resolved in a disciplined way instead of being dismissed as minor inconveniences. Repeated small defects often reveal deeper weaknesses in planning, review, or communication that QM should address. Once a service is in operation, quality does not become someone else's problem or disappear into routine support work. Operational quality includes whether incidents are handled consistently, whether recurring issues are identified instead of repeatedly patched, whether changes are introduced in a controlled way, and whether backups, recoveries, monitoring, and maintenance are dependable enough to support the business. A system that passed initial testing can still become low in quality over time if patches are applied carelessly, documentation becomes outdated, staffing changes leave knowledge gaps, or data quality begins to slip. This is why mature organizations treat daily operations as part of the quality picture rather than as a separate universe. Good QA in operations means preventing avoidable disruption through standard practices, review steps, role clarity, and attention to recurring patterns. Good QM in operations means measuring service health, learning from incidents, and using that information to strengthen the way work is organized. Quality is not preserved by optimism. It is preserved by discipline after deployment as much as before it. Measurement is another key element because organizations need some way to tell whether quality is improving, holding steady, or declining. Useful measures might include defect trends, service interruptions, rework levels, missed deadlines, recovery outcomes, user complaints, repeated incidents, failed changes, or the time it takes to resolve problems that should not have happened in the first place. The important point is that measures should help the organization understand whether its processes are producing stable and trustworthy results. Bad measures can distort behavior by encouraging teams to make numbers look better while real quality remains weak. For example, closing tickets quickly is not very helpful if the same issue returns the next day, and delivering code on schedule means little if it creates avoidable outages after release. Good reporting connects quality information to business impact and management attention so that patterns are not ignored. Measurement supports learning only when it is honest, relevant, and tied to improvement rather than vanity. People and culture matter just as much as procedures because even well-written processes can fail in an environment where staff are rushed, afraid to report problems, or unclear about their responsibilities. A healthy quality culture makes it acceptable to raise concerns early, admit uncertainty, ask questions, and slow down work when important risks have not been addressed. That does not mean the organization becomes hesitant or overly bureaucratic. It means teams understand that catching a weakness before release is far less costly than apologizing for an outage afterward. Training is also part of this picture because people cannot follow quality expectations that were never explained or practiced. New employees, contractors, and even experienced managers need to understand how the organization defines acceptable work, what evidence is required, and when escalation is appropriate. Quality grows stronger when communication is open and expectations are clear. It becomes weaker when people feel rewarded for silence, shortcuts, or optimistic reporting that hides unresolved problems. Third-party relationships add another layer because vendors, service providers, and contractors can influence quality just as strongly as internal teams do. If an organization depends on outside parties for hosting, development, maintenance, support, or security functions, it still needs a way to define quality expectations and verify that those expectations are being met. A vendor can deliver a service that technically satisfies the contract while still creating poor user experiences, slow issue resolution, or weak control practices that hurt the customer organization. That is why quality management extends into contract terms, performance monitoring, communication channels, escalation procedures, and periodic review of results. Organizations should be clear about required service levels, documentation standards, incident handling expectations, and accountability for defects or delays. Beginners sometimes assume outsourced work transfers the burden of quality to someone else, but that is not how it works in practice. The organization may delegate tasks, yet it still remains responsible for managing the relationship well enough to protect service quality, user trust, and business continuity. There are several common misconceptions that can weaken quality efforts if they go unchallenged. One is the belief that quality slows progress, when in reality, poor quality often creates far more delay through rework, confusion, and repeated incidents than preventive discipline ever would. Another is the idea that quality belongs only to testers or auditors, even though good outcomes depend on analysts, developers, administrators, managers, support teams, vendors, and users all performing their roles clearly. A third misconception is that quality means making everything perfect, which can cause people to dismiss the topic as unrealistic or too expensive. The better view is that QA and QM aim for consistent, appropriate, controlled outcomes that match business need and risk tolerance. From an audit perspective, this matters because an auditor will want to see whether quality practices are defined, followed, measured, and improved over time. Weak quality management often shows up through repeat findings, unstable services, incomplete documentation, unclear approvals, or a pattern of preventable problems that management has learned to accept as normal. By the time you finish studying this topic, the central idea should feel practical rather than abstract. QA and QM in IT are about creating an environment where good results happen consistently because expectations are clear, processes are disciplined, checks are meaningful, and improvement never fully stops. They matter because technology that merely works sometimes is not enough for organizations that depend on systems and services to support operations, decisions, customers, compliance, and trust. The strongest takeaway is that quality is not a decorative extra added after the important work is done. It is part of the important work itself, from requirements through operations and from leadership choices through frontline execution. When you keep that mindset, you start to see quality not as paperwork or delay, but as one of the main reasons stable organizations stay stable and dependable organizations remain worthy of confidence. That perspective will serve you well as you continue through the rest of your CISA studies.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.